So first and foremost, thank you all for coming. My name is Mads Gram. I'm a developer on one of the server teams, and with me I have Nikola.
Hello everyone, my name is Nikola, and I'm working on the application side. So I have been working with this product for 15 years, and I'm an AL developer. So on today's session, I will be representing user, because I'm using the things that Matt and his team is building. The main reason why we are having the session today is because we want to introduce ReadIsolation feature to you guys. And to tell you honestly, this is one of my favorite features. So it's definitely meeting the top 10 list. And I like it so much that I made a small animation to explain why. And I hope that you guys will like it as well. So let's say that you have finished the code and it has good performance. And as you know in life, good stuff does not last that long, especially if it is performance, right? Because the thing that is going to happen is that somebody will write just a few lines of code, right? It happens. And these few lines of code will be sufficient to introduce a very bad SQL lock. What does a very bad SQL lock does? It basically kills performance, because that's what the bad SQL locks do, right? In my career, I was saved a few times by the checking gate test that we had, also by the telemetry that we set up. But we know from practice that some of these end up to the customers, and then the customers start screaming. And it is not fun to fix a performance problem ASAP, right? Usually performance problems are difficult to fix. With the ReadIsolation, the idea is that you can fix performance issues with just single lines. So if you throw in the ReadIsolation, and I made the visual animation of this, you can make these bad upgrade locks simply disappear. So it's possible to use for most of the locks, and it is going to fix the performance. So we have used it for several fixes ourselves. So I think we did around 8 or 10 optimizations so far, and it is very easy to fix something that would be very difficult to fix in the past. But it's easy to use as a feature. But to be able to use it properly, you need to understand how the locking works. Otherwise, you will not be able to use this feature because it's a high precision feature. So one of the desires that we would like you to get from this session today is to be able to write a more performant code. To achieve the goals, we decided to start with a quiz. So let's have fun. And if you guys want to participate, you can test your knowledge, if it is going to lock or not. Then Matt is going to explain all the theory behind the quiz. And then we are going to end with some practical suggestions and patterns and tooling that you can use so you can optimize SQL locks. So for the quiz, the examples that you're going to see are the examples that I was myself confused at some point of my career. And I was shocked that it works like it did, because it broke my expectations. And even many internal developers are confused. So if you want to participate, we are going to show you examples of AL code. And then if you think it is going to cause the SQL lock, you raise your hand. If you don't think it is going to cause a SQL lock, you don't raise the hand. And if you're not sure, don't raise the hand, and we will count you as no, right? All right, so, okay, so we are going to start with a simple example. So here we are having very simple code. It's customer.LockTable. And the first question is, when we just run customer.LockTable, are we going to create any SQL locks here? So who thinks? Okay, I can see a few hands raised up. And the thing is, no. We are not going to cause any SQL locks at this point, because here we are just putting the intent that we want to lock the records. Now, the second question is, are we going to cause any locks here? So if you think it will, raise the hands. All right, super, thanks. This was a test question to see who's participating. Yes, so the locks are being caused when you actually read the date. So just calling LockTables syntax does not lock it. I believe it used to lock it in the past before SQL. After SQL, it does nothing. We just wait for the actual records to be read. Yep, so it looks. Now, let's make it more interesting. So let's do on the customer 1 LockTable, and then let's read the data from the customer 2. is the data from customer 2 going to be locked? Okay, I can see few hands, and the answer is yes, it will be locked. And to explain this one, is that LockTable is not connected to a variable. Actually, it is connected to a table, and it is going to be active on that table until transaction ends. In hindsight, we should not have defined it like this. The proper syntax should be like this. So if we can turn back time and implement it differently, this is what it actually does. So it runs on the full table, not the local variable. Okay, let's get a bit more complex. So here we are going to modify customer, and no questions here regarding the locks. And the question is now we are taking a different customer variable and we are doing find last. Is it going to lock? All right, you guys are good. So yes, it is going to lock. And the explanation here is that as soon as you start a write operation in AL, it is going to lock subsequent reads. So it locks. Exactly the same example, but instead find last we are doing count, and count is a no row operation. Is it going to lock or not? And okay, few hands up. You guys are quite good. Yes, it locks. So this thing, I was really surprised myself, but basically any read operation is going to do a lock, and in this case it's going to be a bad lock, because these examples usually cause performance degradations. So we have this example, and this is like delete all, and then we are going to do a find set on an empty table. So no rows are read from the database. So what do you guys think? Is it going to lock or not? Yes, we can get a lot of hands. Excellent. So yes, it locks. And if no rows are returned, the behavior from the platform is that the entire table is going to be locked. So no other sessions will be able to insert until this transaction ends. In reality here, we are actually having two possible bad locks. If you do delete all on the empty table, it can also lock the entire table. And if you do a find set on an empty table, it can also lock the entire table. Now, here, what is going to happen when you do the new customer.insert? So who does it think it will lock? Okay. So the answer is yes, it locks. And it is going to do an exclusive lock on this customer record. And the interesting thing is that even if the .insert fails, we will count it as a write operation, and we will start locking every subsequent reads from the customer table. Now, this is my favorite example. So here, we are doing a lock table on detailed customer ledger entries. We are finding the customer, and then we are calculating balance on the customer. So is it going to lock or not? Yes. So the answer is yes, it does. So this is very confusing. Most of the people say no, because they expect that we are using some kind of SIFT indexes and things. No, SQL will do the lock here. So we will lock the detailed customer ledger entries. And it is usually a bad lock, because we can lock a lot of records. Now, if we do it like this, so we do the lock table on the customer, and then we do the calc fields, do you think it is going to lock or not? So some of you guys are really good. And the answer here is maybe, because it depends. So if there was a write operation on the detailed customer ledger entries, we will lock it by another method. If there wasn't, we will not. So here, we might end up with the lock or not. So you have seen 7 locking examples and 1 maybe. And basically, we have shown you the most common cases that are causing the locks. So with the desire just to share which problems we have seen. The learnings is that the lock table works until the transaction ends, and it's not connected to the variable. And starting a write operation is going to lock all the records read from the table. And it's especially impactful if you're doing count, calc fields, calc sums, find sets, modify alls, delete alls. They have the potential to lock the entire table if it is empty, in these cases for the bulk operations. And the write operation is going to do an exclusive lock on the records modified. Now I'm going to hand it over to Matt, that is going to give you much more insights into this.
Yeah, thank you, Nikola. So we have to go a little bit back, right? We have to go back to maybe university, maybe school, theory, right? Back in those days. So I think most people have some kind of inkling or idea that AL as a language is single-threaded, right? All the in-memory data structures used, dictionaries, list, whatever, are single-threaded. There's no two people or two sessions interacting with them, meaning we don't need general kind of semaphores, mutexes in memory for you to lock and unlock, right? Because you just can't have data races because there's not two sessions reading it. The only place you can really have it is when you go to the database. So for AL, all the locking we do towards tables is relegated to the database. So you can, it would be nice to say they handle all of it, but it's not quite true. We do have to do some manual handling of it in the platform. For writes, though, we mostly just let SQL Server do exactly what they want to do. So we just emit a nice little SQL query that says delete or modify or whatever it does, and then SQL will take the locks it wants to take for that statement. That will normally be a exclusive lock. But I cannot 100% guarantee that, because we are at the behest of what SQL does here. For reads, however, in the runtime, we make some decisions, and we apply these hints that you can see here: read, uncommitted, recommitted, repeatable, read, update lock. We'll go into depth what they mean a little bit later, but we will apply them for all reads. And this was what we also saw with Nikola when we applied them. So another aspect you probably know about AL intuitively, I would guess, is that AL code is transactional, right? So all database operations, at least, are transactional. So if you write to a single instance code unit, that's not transactional. But if you write to a database, it's transactional. So all the database operations will be committed or rolled back in once, unless you commit in the middle of, well, that's your own choice, right? But it also means that when you end up taking an update lock, either implicitly or explicitly, then that one will be held for the length of the transaction. So if you begin taking locks early, like let's take an example of posting a sales order, right? So I just did this, and you can maybe read that, I don't know. So if this is in time order, so this was captured every single method, start and end, every SQL query, and I visualized it here. This is precisely what happens when you do a posting of sales order with base app. I don't know if you have customizations, you probably do. And let's imagine the first thing we did was we took a lock. Right now, you're going to hold that lock for 2.5 seconds. Now, of course, this was not super slow. I'm sure everyone knows of operations that takes way further. I've heard of some of them. My customers tell me about it. So, sometimes someone have things that maybe take 11 hours. If you take a lock on a crucial table for 11 hours, yeah, that's probably going to be a problem. Now, what kind of tables I should have asked, what tables do you think will be locked? This is the tables that will at least be attempted to be locked. When I say attempted, it is, we don't know if you actually did go to SQL when I captured this. So if they had gone to SQL after this is the full list of all the tables. There's some quite significant ones there. I'm not sure of precisely which ones are implicitly taken, so you did a write toward them, and which are done by LockTable. I know Nikola told me some of them.
Some of them we should not lock, so they're not expected, so it is just the side effect.
Yeah. So,
but again, after the fact, sometimes it's really hard to tell if it should be locked or not.
Yeah. So, to understand these locks, and as I told you, the locks are held by SQL. So we kind of have to understand a little bit about what SQL does. And I promise you I'll explain this now. So these are the two most important in the current world, and 21 and down, version 21 and down being lower. We mostly use these two. And I know that there's one more thing. If anyone used transaction type, set that one to anything like update or snapshot. I have never seen it in real AL code. I checked all of our code. It's only used in tests, so I'm not going to cover it here. If you are setting transaction type yourself to update, you will have a little bit different behavior. We can talk about that later if anyone is doing it. I don't think they will. So read uncommitted. This is the default way we read. We allow for reading uncommitted data, so dirty reads, which means you read, someone has a session going, they write into the database, you come and read it, and say, oh, cool data. And then that other session rolls back, it errors. So the data has never actually been in the database for real, it has never been committed. So when you then try to read again, it's gone, right? So this is kind of a choice that was taken long before I started. Maybe it was back when Nikola was there, I don't know. I guess yes. No logs will be taken, right? And you don't even have to wait for update logs, exclusive logs, all of that things. You can just continue along, which is also why you can get dirty data. Now, the other one is update log. This was what we saw in the quiz a lot of the time. After calling LockTable, after doing a write, all reads will by default be done with update log. That will take what's called a U-log in SQL, and we'll see a little bit more about what is U-logs and S-logs and something like that later. There's no uncommitted data, so that's, I think, good. I think most people would agree with that. However, update logs will be placed on all the rows you read, which means they will stay valid for the entire transaction. No one can delete your data you logged, but it also means you are holding that log for the entire transaction. So if someone else is trying to read with update log or try to modify it, they have to wait for you to be done. And then we have exclusive log. It's the same as update log, just stricter. It will block other things. We'll see that. There,
yep,
right now. I clicked the wrong button. It wasn't, it was my fault. So this is, I want to give you the technical term here, because then you can Google it. So this is the SQL Server Lock compatibility matrix. It specifies on the first column, you are trying to come with and request the following type of lock. Like let's say it's a no lock S or U, X. And then on the header row, there's what there's currently applied for that row. So let's take an example of this together. So let's say you're coming requesting with no lock, so you're doing a read uncommitted, and you are trying to ask for a row that currently has an update log on it. So this will be an N, which means no conflict. This means you are not blocked. You are allowed to read that row and continue on, right? Let's take another example, something maybe that blocks. So this is really interesting because this is what we have when we do LockTable, both of two sessions doing LockTable and trying to read. We have, you're coming with an update log, and there's already an update log there. It's a conflict. This means the latter operation, the one trying to read now, will have to wait for the former to release their log, relinquish it. Yeah. So, you know, I gave you the simplified version there. This is a real one. I don't think I'm going to go through all of them or even a few more of them, but the reason why I brought this one is you can see there's a few more things than just update log. There's range logs. There is intent logs. Most of the time, you don't have to care about it. But if you end up in a situation, you can always go back to this. Just Google SQL Server Lock compatibility matrix or look at these slides, and then you can, you know, match it like I did there. And you can figure out if it's compatible or not. Good. Now, again, you know, there's many complexities, and one of these is really annoying. But it's actually for good reason is there. It's called lock escalation. Lock escalation. So most of the time when you go down and you modify a row or you read something, you put a lock on that row, right? And maybe you do 10, and you know it's all fine, you lock those. But at some point, SQL Server, to conserve memory, will go, you have locked a lot of rows now. This is not very efficient. You're spending so much memory just on having locks. And it will actually group all the locks together in what is called pages. So a page is like an 8 kilobyte data structure type. And it will transition from locking on the rows to that entire page, or multiple pages it could also be, which means that you can actually end up locking rows you have never read, as long as they're just in that same page. We have seen some really interesting bugs
Yes.
on this. So keep that in mind, and it can escalate further up. Right. So now we're kind of done with the SQL. Now we're going into kind of how the runtime decides based on knowing SQL these things. So I made a very simple rule set, I hope it is, which is reads are done with read uncommitted as long as no writes or LockTable has been done on the table in the current transaction. I should maybe have underlined table here, because it's not the record instance. It's not the record variable as we saw in the quiz, which might have tripped someone up. It is the entire table type. So for example, customer or currency or whatever it is. And it's for the entirety of the transaction. If you call LockTable at the very start, it's going to persist throughout the entire thing unless you do commit. Right? And then the opposite, if you did do a write, we are doing update lock. Now I think it's easy, so let's take a little example here. We have some relatively simple code, and so let's try to apply this, right? So we haven't done any writes yet. This is an action. Let's assume there's no on before action triggers or any trickery like that. And we're just going to say, which rule do we apply? Well, to me, it seems like it's rule 1, so that should be a read uncommitted. And luckily it is. I ran through this code, by the way. It is correct what I'm telling you here. And then we do a delete. And maybe someone was tripped up by like delete, but that's not LockTable. Well, delete, actually, one of the first things it does is it just calls LockTable under the hood. I'm sorry to break it to you, but that's like the dirty secret under the hood, right? So when we do cur.find first, we, of course, go to the rules, and it, to me, it seems like a rule 2, and that means it should be update lock. Right. Okay, let's continue along. Now we're talking about another variable, another record instance, another method. So which rule should we apply? Well, we still did a write to that table. So of course, it is 2. And then we come to cust.find first, a new table. We haven't touched this table before. So we can go again, rules, it's number 1. There you go, read uncommitted. Now, I think these rules are something you can actually kind of apply to your code to some degree if you really wanted to, but that's a bit tedious. It sounds kind of boring if you had to do that with a couple of thousand lines, maybe more, I don't know. So in version 21, we introduced the ability to see which locks you are holding in the current transaction via Visual Studio Code debugger. So you can expand this database statistics and then expand locks and then see UI. The syntax is maybe a little bit weird here for some people. Access, that doesn't mean anything, it just means access type. And then the next thing is what type of locks it is. And then more specifically, what kind of locks from SQL it is. So it's a key lock in this case. That's maybe a bit more technical than what we'll dive into here, but it's good to have it. Another option is, and I'm very sure you can't read this, but we added it there so you can copy paste it for when you need to do advanced analysis. You just execute your SQL statement, and then, or you get AL to execute it for you, right? You run it, and then you fire off this query, and that will return you precisely the logs that are being held in SQL for you. This is actually what the Visual Studio Code debugger does under the hood. Whenever you hit a break, well, whenever you expand that thing, it just fires this SQL query, reads it, and presents it to you in a relatively nice way. So telemetry, I don't think you have been on a session without some people talking about telemetry, especially if they're from Microsoft. So I'm also going to talk a little bit about it. But actually, Kenny, he did it better than I could do. So go read his slides. They're right there. There's both the QR code and there's a link there. It's from 17 to 21, where he talks about how can you find out who took locks and who was a victim of a lock timeout. I really recommend you to read that. It's better than what I would have done.
Yes, and internally, most of our optimizations are done through the telemetry. So we are monitoring telemetry, and this is driving the optimizations that we do.
Yeah, exactly. So there was a question on FlowFields, and at least internally, that was one of them ones that tripped up a lot of developers, I would say. And it's this problem of like, well, what should actually impact if a FlowField reads with read uncommitted or with read with update lock. And in this case, it's the target table, right? So this is defined, I believe, on customer, and it's the balance, right? And because it's reading from the detailed customer ledger entry, it is actually that table state that defines if we're going to read with read uncommitted or update lock. Now, in version 22, we wanted to give you some more control about how you read. Because previously, there's only really been one control. That's you can have higher isolation levels, you can be more strict, you can take more locks, and that was kind of it, right? LockTable or do a write. But we found that for a lot of cases, it's like you might have done a write earlier, and then later in the transaction, you actually want to read something, and you might be okay with saying, I don't need the strictest of guarantees here. I don't want to lock the entire table. Let's say you're doing a count or Findset or something like that. So we introduced a new concept, and this new concept we wanted to be based on a better way of specifying it, maybe some more control over it. So we decided to do it on a per record instance basis instead of a table basis. We're going to see some examples of that also. So it ignores the current table state. You know, if someone had called write or LockTable earlier, if you use this feature, it doesn't influence any other instances. So if you have 3 records, it doesn't impact the 2 other records there or the further ones in the future. As I said earlier, we only apply these hints for reads. We don't do it for writes. So this one also only works for reads. So we have already seen these 2, the read isolation values. You can, of course, choose those 2. I'm not going to go through them again. But we also gave you access to 2 more options. And these, of course, maps to the SQL ones, right? So you can go in and say, I want to read the data. I want to read it read committed, which means you don't have dirty data anymore. And the reason why you don't have dirty data is you place a shared lock on the table, but only for the duration of the read, right? So it's kind of a nice way to say, okay, I want some kind of guarantees, and I want them not to lock to people too long. I think this is really the best option you have, and it is also what we recommend if you're using read isolation to kind of give a good guarantees without locking people.
Yes, in some cases you may need to use the read uncommitted. We'll show you an example a little bit later.
Yeah.
So because they differ a bit.
Yeah, but if you need this idea that like data stays consistent for a long time, then you actually need to place these locks for the entirety of the transaction. And this is what you can get from repeatable read. You can go in and say, hey, I want to have this lock. I want other people to also be able to read from this row, but I want it to stay consistent for the entire transaction. And this is what repeatable read can give you. It doesn't do uncommitted reads, which is nice. This is kind of the option if you really need this. If you really need your data to stay consistent, consider using this.
Now, if we go back to the practicalities, right, and we go back to the quiz, and so if we would take a look at this specific example, right, how could we make it better, right? How can we eliminate this lock that we have on the count? So if you replace this code with the following 2 calls, and this is single liners, so we have replaced the lock table with update lock, and then we are finding last. And then on the second instance, we are being explicit and we are setting read committed. This way, we are just going to lock the last record on the customer 1, and we are also going to not lock anything on the second instance. It's a very good thing to specify it on the customer 2 that you want to read uncommitted because you may not know in which state you are. So just to avoid the maybe state, which may or may not lock. So this was a simple optimization that is going to lead us into the pattern that we have here. So yeah.
Yeah. So we kind of have these 2 patterns that we want to present you. And one of them is what we call temporary heightening, right? So you might be in a situation where you need to go in and say, I need to ensure that whenever people go through this code, they need to ensure that no one else can read it, right? So GL entry or like any of the get next entry node does it for regulatory purposes, right? You can't have 2 of the same entry node. So the way we previously did that was this kind of LockTable way of doing it, finding the last one, and then we're sure nobody else was reading that and doing this trick. This has, of course, the negative impact that, like, if we do this early on, and we then query the GL entry, well, I mean, this could be done for any table, right? But if we then query something later, we might end up taking really wide locks, right? Or we can even see lock explanation, and then suddenly we're locking everywhere, right? So the new way to do this with ReadIsolation is to just be more granular, right? Go in and say, okay, I know I want to read that one with a lock guarantee, right? So we go in and say, okay, I need an update lock on that row, just that one row. We take it out, and then whatever happens later, they will have to, of course, also think about, do we want to read here with update lock? Well, then they just specify that. But there's now an option for them to do it without it just implicitly locking everything. So the way we think about like ReadIsolation is that it's pretty much better than LockTable for almost all scenarios. There is a few places where we don't really know about, because it has always been LockTable, right? So we don't know if changing it here to ReadIsolation update lock will break anything because someone had depended on when they begin reading, they actually expected to take those locks.
Yes.
So there's an interesting game there.
So the thing that we would recommend is that for all of the new code that you write, that you use this new syntax, because then you're very explicit of what you're locking. And if you would ask us, are we going to replace this specific code in the app, we are hesitant to do this because we might be missing other locks. You know, this lock table that we currently have is probably locking additional things, and if we remove it, we could introduce regressions. So for this reason, we are telemetry driven, and we are eliminating the worst performance offenders, right? So yeah. So I would also, if you need to replace the existing code, do it with caution, because it is unlikely, but it can cause regressions.
Yeah, and another thing about, and I think both of them actually is very, very important when you think about event subscribers. Because when you're thinking about event subscribers, you have some idea of the context you're being called in, right? You subscribe to an event, but you're not actually really sure what happened before you, right? Maybe there was another event subscriber. Maybe that event subscriber is the different way around. We don't guarantee order, by the way. So, you know, you don't fully know the setup you are in. So, you know, if we have this code and you do this Findset, most of the time it's probably fine, right? Most of the time you're probably not locking anything, right? But you're not 100% sure. And maybe there was an event subscriber that called LockTable just before you, or maybe it was a lot before in the transaction. So this is one of those things where you can now avoid that, right? You don't have to think about it. You don't have to be worried about it. You can just specify your intent explicitly. So we think for event subscribers, this is going to be a really strong thing, because event subscribers aren't magical. I mean, maybe they kind of are, right? But they're also just AL code, right? They behave the same way. There's no special, like, oh, transactions works differently. No, they work the same way.
Yes. So we highly recommend using them in the event subscribers. Yep. All right. So.
Yeah. So when we were writing this code, we had this little kind of a discussion between us. How should you specify that you want to be able, so we saw this from the quiz, right? So here, you know, pretty obvious behavior when you saw the quiz and you now have the explanation. Maybe it wasn't obvious to start with. But when we came to ReadIsolation, you can't, because it's specified on the record instance, and I really want to point this out, it's on the record instance, not the variable, not the table, record instance, right? So if you pass it by var, by the way, it stays there and you can, still is useful. But how would you specify this on the customer record instance if you didn't, like how would you specify it, right? Because it pertains to the record instance, but we saw previously it's actually the table you're reading on state that defines it. So we kind of had to say like, okay, FlowFields behave a bit different than how we generally say when you're using ReadIsolation. So ReadIsolation that you specify on the record instance also counts for FlowFields. So you can also override for the flow field behavior, even though the flow field has someone that's called LockTable on it. You can also override that with record ReadIsolation.
Yes, and this is a great addition, and many developers are simply not aware that you can optimize the flow fields by simply setting them on the parent record. So it's excellent for avoiding locks on the calc fields. For the question also that we had at the beginning with 2 bad locks, and we have been seeing this kind of pattern happening a lot, so we are going just to go through it here as well. The way how we would make sure that these locks are not happening is by simply refactoring the code similar to what we have done. So we would set the read isolation here to read uncommitted, because we want to delete all of the records, even the dirty ones, right? And then we would check if the table is empty, and then we can delete all. Because the problem with delete all is that it is going to lock the entire table if it is empty. And read isolation does not apply to write transactions. So here, unfortunately, you need to set this check is empty before you call delete all to avoid the table lock. And then this other instance that we have, which is doing Findset, is still going to use the read isolation from the first line at the beginning. Even though you did the write transaction, it saves the state, and it is not going to do any locks when it reads the date. So be sure that if you want to change it, then set it above the Findset. Yep, so this was the addition that we did. Then we have the repeatable read, which is going to help you to keep the read isolation until the end of the transaction. So if you want to make sure that this is going to last until the end of the translation, you should keep it. And yeah, that's a very short one.
Yeah, and before you go on to telling people how to be smart, there is one little caveat that we didn't have a slide for, but it is when you have set read isolation on a record, and you then on that record call LockTable. I don't know why you would do this, but if you end up doing it, that's going to reset the read isolation. I just want to warn you, so if anyone is trying to do this and then wonder why it reset, that's just the behavior it does. So
it's similar as writing a different level of read isolation on the same record. So we believe it is expected.
Yeah, we asked the developers internally what did they think was reasonable, and this was what they felt was reasonable. I hope you guys agree.
So our strong recommendations for you guys after this session is for existing code refactor as you need, and do it incrementally. Focus on the worst offenders that you can find either from the telemetry or from testing. For the new code, we strongly recommend to use the read isolation. Don't use lock tables anymore. And also, if possible, in many cases, it helped just to restructure a few lines to move them up. So it's better to do reads before writing to the table, if possible. Also, we recommend to cache the read results, so you don't call them too often. And we recommend to try to write the small transactions. And in case that you need to write a longer processing code, ensure that the code is re-entrant and try to break it into smaller chunks. The things that we have introduced in the previous few releases is ignore commit, and this can help you you can write the re-entrant code. Unfortunately, we will not have time to cover these kind of patterns in this session, so it could be a topic for some of the following sessions.
Yeah, and one more thing about, I was talking with someone earlier over here, they were saying one of the reasons why they're here is that they sometimes have this lock timeout, right? So you had to wait for a lock for 30 seconds, then we throw an error, right? Bad performance, bad for the customer, of course. But one of the ways that you can, if you need to take the lock, right? One of the ways you can also do it is just by making sure you hold the lock for a shorter time, right? It doesn't always have to be we avoid the locks 100%. Sometimes it's just about making your code faster while you're holding the locks. And there's plenty of other good resources to learn about that, of course. But that's also a very important way to get around locks.
All right. So this was all. Thank you very much for your attention. And we hope that you liked it. So, yeah. All right, so we are open for questions.
I think we have a cool little thing we can throw around.
Yes.
So I'll just start here. Ah, good.
Hi. Do you understand it right that the good approach is just to specify the ReadIsolation for each read?
You can.
Well, okay, so I just want to make sure. So you have to do it for each record instance, right? So if you're doing, let's say you're doing you have a record instance, a customer record instance, and in the same record instance, you're doing 5 reads. Then you don't have to do it in between every single one. The state stays there for all of those reads. Now, if you call clear, of course, it will clear it, right?
Yes.
I mean,
But I mean from the pattern perspective, from the writing good code. So if you make a habit to specify it for each read, then you're conscious about what kind of isolation you need right now.
yes, I mean, that's what I would hope, right? That everyone is conscious about what kind of isolation level do I actually want. Like, put that into their mind. Do I need this to be super strong? You know, like, for example, that GL entry example. That is an example where some developer out there had a really good reason, regulatory reason in this case, probably the best reason, that they actually needed to have such a strong guarantee. Now, of course, it can't be that I don't think everyone should go out and always think about this every single time, but, you know, think about it in kind of a moderate amount. Like if you have a hot path code that you're calling all the time, yeah, be a little bit more explicit there.
So one of the cool abilities that we got is that now you can think about, do you want to read the dirty data or not? That was not possible in the past. So you cannot ask, like, is this really persisted or not?
Yeah.
So this is the capability that you got. So you can start thinking about it when you write the code.
And I also wrote, Kenny said that you're going to switch to read committed. Is it like a plan or is it just out of the session? Sorry if I...
The code is on my laptop somewhere. I don't think we're going to guarantee anything on that, unfortunately. But there is plans in the future to look into, can we change what happens after having done a write? Because as you know right now, the write leads to update lock. What if it led to read committed instead? We're not saying we're doing it, but think about it. Tell me if you think it's a good idea.
My personal, thing that I super hate is the fact that delete all locks the entire table on the empty table, or that count locks. That's something that is not expected, but it's the existing behavior. I would like that fixed as well. So,
any more questions? Oh yeah.
A simple one, not very clear to me. Is this only session context? So what you told about is not affecting any other sessions?
No, just...
So if you have that lock that does not persist in the other sessions with every read you do, but only in your own session?
Yeah, so if you mean LockTable or doing a write, yes.
Yeah, okay. There was one. And the other one was, are you considering to make this a setting on the service tier that you could set my read would always be this isolation level? I mean, you had a recommendation on use this one, then you could actually also make a choice. This is what you could do on your service tier.
That's a good idea. I will take it back home to my manager and ask him if we should maybe do that.
And look nice at him.
I cannot promise anything, of course, but anyone else?
Yeah, we have time for maybe 1 or 2 more.
If you want to ask something, I can't see you, then... No, I don't see anyone, then...
If you have more questions, I'm staying afterwards, so feel free to approach. Thanks all.